No, pi r squared is not a variable. That is your equation. You have to pick the variables from your equation. I've seen a lot of
Yeah.
people make the mistake.
Okay.
Okay, can you see my screen? We're on number 3, right?
Yep. Yeah.
Okay, so we have, where'd my pen go? Okay, so we have A is equal to pi r squared. What are your variables in this equation?
Pi. Oh,
Is
wait.
pi a variable?
No, pi. No.
No,
Our
A
variables
is a
are
variable. And what else
A
is
and
a
R.
variable? R is a variable, not r squared, just r. Okay, just r.
Yep.
Okay, so we have to figure out which one's dependent and independent. So if I have a circle, right, and it has a radius from the center to the outside of the circle, the radius is r, right?
Yeah.
So if the radius changes, what does that mean for the area of the circle?
The area will change, so R would be dependent.
Exactly. No,
So
r is not dependent.
Never mind. Okay.
Sorry, no. If the radius changes, the area changes. So what does that mean?
That the radius.
That radius is the independent.
Exactly.
Righty. Oh. Okay then. Can we do number 4?
Can we do which one?
Before.
Sure. Okay, so during a sale at a shoe store, shoes were 25% off the original price. Which statement best describes the functional relationship between the sale price and the pair of shoes?
Popped up on my screen.
Yeah.
Popped up on my screen. It says this free meeting will end in 10 minutes. The meeting host needs to upgrade or something.
Yeah, we just have 10 minutes. That's what it's telling us.
Okay.
Okay then.
Okay. All right. So let's say you see a sales tag and the price is $20, right? It's 25% off, 25% discount, so minus 25%. Then that is going to be what, $16?
Yeah.
Okay. So let's say we see another price. Let's say we have one is at $50. And then at 25% off, it's 25% off of 50.
I know this. Hold on.
It's not a trick question. You can use your calculator.
Yeah. No. Oh, okay. That. No, you don't need to use it.
Isn't it 46?
Would it be 46?
No.
I don't think it is.
I don't think so either.
20% would be $10. So 50% would be what?
25% of 50 would be 12.5.
12.5.
So,
okay, so it'd be 37.50.
Yeah.
Okay, so the new price is $37.50, right? How am I getting the new price? So this is the original price and this is the sale price. How am I getting the sale price?
By subtracting the percentage from the price, from the original price.
So what depends on what?
The original price depends on the sale thingy.
Are you sure? How am I getting the sale price?
No.
I'm confused.
How am I getting? Okay.
No. The sale price depends on the original price.
Exactly. Okay. Do I know what the sale price is if I don't have an original price?
No.
So the sale price depends on the original price. So which is the independent and which is the dependent, Mayhair?
The price is dependent and the original price is independent.
Exactly.
Smart guys.
Yep. Well done.
Okay.
Thanks, Mo.
No problem.
What did you guys put for the customer at Lulu, and what did you guys put for number 2?
Ooh, okay, wait. Let me find it. I said the independent variable is the time spent in the checkout line, and I said that the dependent variable is the number of customers, because it depends on how many customers there are, how long it takes.
No, the independent variable would be the number of customers. Yeah.
No.
Okay, you have to think about it, right? Because the time you're going to spend in line is dependent upon something. So the time can't be the independent, it has to be the dependent.
Yeah.
Oh, wait, isn't that what I said?
Nope.
Oh, no, I did.
Wait.
That's one of those trick ones that we give you to make sure that you understand that time is not always independent.
Oh, okay. So the number of customers depends on the time spent.
No. When
Because
you go to the store, right, what determines how long you're going to stand in line
the number of customers.
that are already in line, right?
Yeah.
Yeah. So the number of customers in this case would be the independent, and the time is dependent upon how many customers are in line.
But couldn't you just say like the number of customers? I don't know. Okay. Okay. What is the relationship between a constant difference and a slope?
What is the relationship between, where are you?
No, it's where it says understand
Mm-hmm.
and it says understand the relationship between a constant difference and slope.
Yeah. Okay, so remember when we talked about the constant difference, right? So let's say I have, where's my pen are? Okay, so we have x, and let's say I have y equals 2x minus 1, right?
Yeah.
This is my function. So let's use negative 1, 0, 1, and 2. So if I plug in negative 1, that's 2 times negative 1, which is negative 2 minus 1, that's negative 3. If I plug in 0, I end up with minus 1. If I plug in 1, I end up with 1. And if I plug in 2, I end up with, it looks like 3.
3.
Yeah. Okay, so remember that we said the slope, we can take any 2 points, right? We can use the equation m equals y2 minus y1 divided by x2 minus x1.
To find the slope.
Yeah, to find the slope. So let's take 2 points, right? Let's pick the easiest ones. Okay, let's pick those two. So I have y2, which is 3, right, minus y1, which is 1, divided by x2, which is 2, minus 1. So 3 minus 1 is 2, and 2 minus 1 is 1. So what is the slope?
2.
2. 2 over 1. Okay, so now let's look at the constant difference ratios, right? Let's find the change in the x's in the table. What are those changes between the x's?
Adding 1.
Okay, it's adding 1 each time. Plus 1, plus 1, plus 1, right? Now let's find the change in the y's. Yeah.
Plus 2, plus 2, plus 2.
Plus 2, plus 2, plus 2. So we know that the ratio, right, the difference ratio for linear is the change in y divided by the change in x, right? That's the first difference ratio, correct?
Yep.
Okay, so we know that the difference ratio is also 2 over 1, right?
Yeah.
What is that also equal to?
2.
2.
What did we just find here using the equation?
The
The
2
slope.
over 1. Yeah.
The slope, right? So the slope,
Yep.
for the linear, the slope and the difference ratio are the same. But for the quadratic, it's not the first difference. Which difference is constant?
Second.
It's the second difference. Okay? So a constant difference in the linear, so for the linear, the constant difference and the slope mean the same thing. The slope just means that you have a constant difference. It's just a measure of the constant difference.
I see.
Okay. Wait, so I had a question.
Yes.
How do you figure out like the rate of change when in the table we're given the x values are not going up by ones, like when they're going up by say 3 and then 2 and then stuff like that.
Key thing right here. The change in y over the change in x. That's the ratio. It's the rate of change.
Okay. No, so what if x is going up by a different number every single time?
Yeah, okay. So let's say we skip some numbers. Uh-oh, what happened to my... Okay, so let's say I had a table, and let's say I skipped some numbers. So I have -3 and -3. I have 0 and -1. And let's say I skip to like 5, right? So if
Yeah.
I plug in 5, 5 times 2 is 10 minus 1, so that's 9. Okay, so let's look at
Yeah.
the difference ratios between these. So from -1 to 0 is +1. From 0 to 5 is what?
5.
Plus 5. Okay, so
Yeah.
now let's look at the changes in the y. So this is x and this is y.
Yep.
So the change
Plus
is
2.
+2. But what's the change here from -1 to 9?
Plus 11.
No,
Oh, plus 10.
plus 10,
Sorry.
right? So when we
Called
look at
it.
it,
Yeah.
so when we look at it as a ratio, right? The change in y divided by the change in x, it doesn't matter how much the numbers skip when we're talking about the linear function, right? It's still going to be the
Yeah.
same. If I find the change in y to be 10 and the change in x to be 5, it still comes out to be 2 over 1. Just
Oh, okay.
find the change in y over the change in x to be 2 divided by 1, that's still the same thing. They still come out equal, right?
Wait, where did you
Okay.
get the 2?
Yes, who has a question?
Where'd you get the 5 from?
Oh, I just put in different numbers. I said, let's skip some numbers and let's say we put in a 5 and we got out 9. I made it up. I gave it to you.
Got it.
Yeah, the numbers on the table will be given to you. You don't have to make them up.
Okay.
Not for the difference ratios, only when you're graphing.